Hi friends, today we're going to learn how branch and bound method is used for solving a traveling salesman problem. Before we go inside a branch and bound method, let us first understand what is a traveling salesman problem. A traveling salesman problem is a network optimization problem wherein you have a finite number of points called cities, and starting with a given city, the salesman has to visit each of this city once and only once and then finally come back to the starting city with the shortest possible distance. The route taken by the salesman would be called a tour. The salesman will be said to have a complete tour if, starting with a given city, is able to reach each of this city once and only once and then finally come back to the starting point. Else, it's bound to have multiple subtours. Now, to understand the branch and bound method, let me take a very small example. So let us say a tourist is visiting Delhi and is staying in a hotel somewhere in Paragon's and is planning to visit 5 different tourist points. For this, he is hiring a taxi who is going to charge him on the basis of the kilometer traveled. Now the objective of the tourist is to identify a route to visit these 5 different tourist points from his hotel in such a way that each of these points are visited once and only once and then finally come back to the hotel with the shortest possible distance. For this, I have constructed distance matrix. Over here, 1, 2, 3, 4, 5, 6 are representing these 6 different points. 1 to 2 is the distance between from Paharganj to Red Fort. 1 to 3 is the distance from Paharganj to the Qutub Minar. 1 to 1 is not allowed. That's why I've taken a very last number. So this is a distance matrix. Over here, Dij is not necessarily equaling Dji, meaning 1 to 3 is not necessarily equals to 3 to 1. Now, the branch and bound method starts with solving this distance matrix as an assignment problem. If the solution of the assignment problem provides us a complete tour, then that solution will also be a solution to the TSP problem. Now, I had already explained how an assignment problem is to be solved using the Excel solver. See, this is the complete branch and bound method of the problem that we have discussed. The first solution is this is the first solution, and this solution is the solution of the given distance matrix as an assignment problem. Now, these are the subtours. Till the time we have a complete tour, this cannot be a solution to a TSP solution. How do we write these subtours? Let us see how we write these subtours from the assignment solution. So this is the assignment. This is a worksheet for computing or calculating the assignment solution. Let me find our assignment solution first. This is the space for the objective function. The objective is minimization by changing this solution space, the constraints, the row constraints. Column constraints. Okay. This has to be ticked, simplex has to be selected. Now it's solved. 47 we have the solver found a solution, all the constants and optimality conditions are satisfied, right? So let's see how we write the subtours. So we're starting from 1 is Paharganj. From Paharganj I'm traveling to Red Fort, and then from Red Fort I'm coming back to Paharganj without reaching the remaining points. Hence this is not a complete tour. Then from 3 I'll go to 5, then from 5 I'll go to 3, again coming back without reaching out the remaining. What about 4? 4 I'm going to 6, and from 6 I'm going to come back to 4. So we have 3 different subtours with 47 is the value of Z, and this is what I've written over here. Now this 47 is going to give the lower bound to the TSP, and these are the subtours. Till the time we have the complete tour, these solutions can never be a solutions to the TSP problem. So what we do now is defining the bound. The bound means the lower bound of the TSP problem, which is 47 in this case. We are now going to branch the problem. The branching of problem has to be done on the basis of one of the subtours. But ideally you should select that subtours which have minimum number of connections. By connections I mean the links over here. I have two connections in these subtours. Over here also is two connections. Over here also two connections. 1 to 2, 2 to 1, 3 to 5, 5 to 3, and so on. So all the subtours are of same connection, so you can select any of the three. Now let me select the first subtour. So I'm using the first subtour for doing the branching of the problem. The number of branches depends on the number of connection of the subtour that you have selected. Since I have two connections in the subtours, I'll be having two branches over here. Now, this is the first branch, this is subproblem 1, and this is second branch, this is subproblem 2. Now, the first subproblem is to be defined by replacing D12 by 1000 and solve this as an assignment problem. Right, solve this as an, let me demonstrate this again. I have to replace this by 1000. I say 1000, okay. 100 or 1000, it has to be large number so that this option is never selected by the salesman, right? So 1000. Now let's go to the solver again and solve it. Everything has a pre-filled, so I just have to click solve. Now it's 49. See, the solver found a solution. The constants and optimality conditions are satisfied. I think it's 49 over here. 49, yeah. The route taken by the salesman in this case. So you always start with 1. Starting with 1 is going to travel to 6, right? And come over here at 6, and from 6 is going to 4, and then from 4 is going to 2, and 2 from 2 is coming back to 1 without reaching to 3 and 5. So from 3 is going to 5, and from 5 is coming back to 3. Again over here we are not having a complete tour, instead we are having two subtours, right? And the value of the Z is 49, which is greater than the lower bound that we define over here. So these are the subtours. This is the new value of Z, or value of Z for this subproblem. And similarly, for this subproblem, instead of 5 over here, you're going to replace by 1000 and solve it, and check whether we're having a complete tour or not. Now, in both the cases, we are not having a complete tour, hence this cannot be a solution to the traveling salesman problem. So what we do now is select the subproblem which is having lesser value of Z. Now, consider that subproblem for further branching. So what I've done is I've selected this subproblem 1 because this is having a lesser value of Z, which is 49 compared to 50. So what I've done is I've divided this subproblem into further branches. Subproblem number 3, subproblem number 4, on the basis of the subtour 3553. Why have selected this subtour? Because this subtour is having a lesser number of connections. Now, for this subproblem, what I do is, in the original problem, I put D12 equal to 1000. At the same time, D35 also 1000, and solve the problem. And this is the solution for that. Now, for this subproblem, D12 and D53 will put equal to 1000 and solve the problem, and this is a solution. Again, In both the cases, we are not having a complete tour and hence cannot be a solution to the TSP problem. Now, this is 53, this is 51, this is 50. So the lesser of the 3 is 50. So we consider this subproblem for further branching. So what we do is we select this subtour and divide the problem into two more subproblems. Subproblem number 5, subproblem number 6. In subproblem number 5, we put D21 and D35 equal to 1000 in the original table and solve it. And this is the solution. 53 with these subtours, and for this subproblem 51 with these subtours. Now we have subproblem 3, 4, 5 and 6 without complete tours. So all these four subproblems cannot be solutions to the TSP. Now what I do next is I use this one because 53, 51. So 51 is the lesser value. Either you can select this or this for further branching. I've selected this one for further branching now. Now both the subtours have 3 connections. You can select either of the 2 for further branching. What I've done is I've selected this one and I've divided this into 3 subproblems. Now all the 3 subproblems are solved similarly as we've done in the previous branches, and these are the solutions for this. This subproblem has a complete tour. This subproblem also has a complete tour, and this does not have a complete tour. Now this subproblem, see over here, is having complete tour with a value with the value of z equals to 53. Now we cannot stop here. We cannot stop over here. We never know. We can also have a solution, maybe at z lesser than 53, because till the time you check this particular branch and this particular vertical subproblem by branching it, we cannot conclude that this is a solution. This is the final solution. So what we do is we do branching of this subproblem also and check for the solutions. Over here, Z10 is not having a solution. Z10 is not having a complete tour, and this cannot be a solution of TSP. Z11 is having a complete tour. This should be Z12. Z12 is not having a complete tour. So what are the complete tour subproblems? 1, 2, and 3. So of the three, this I think is having a lesser value of z. Hence, this should be our solutions to the TSP. So what is the salesman doing then? It's traveling from the hotel to the 46 Humayun. From Humayun is traveling next to what tree is what Qutub Minar. From Qutub Minar it should travel to Lotus Temple. From Lotus Temple he should travel to Amsterdam. From Amsterdam he should travel to what is 2 is Redford. He should travel to Redford and then finally come back to Parklands. Right? And this is how a branch and bound method works in the TSP problem. So in the branch and bound method, in each branch you need to solve an assignment problem. Right? And you need to find out that particular subproblem with a complete tour and with the minimum value of z. And that particular subproblem with the one with the complete tour and with the minimum value of z will provide us the solution of the TSP problem. Thank you very much.